Welcome to Arxflix, your go-to channel for cutting-edge AI research summaries. Today, we're diving into a fascinating paper titled Self-Alignment with Instruction Backtranslation. This research introduces a scalable method to create high-quality instruction following language models using unlabeled data. Sounds intriguing? Let's break it down. Here's an overview of their instruction backtranslation method. The process begins with a base language model, like Llama, and a small set of human-annotated examples. The researchers then use a web corpus of unlabeled documents to generate instruction prompts for these documents. This is called self-augmentation. So, what's the big issue they're addressing? Traditional methods of fine-tuning language models usually rely on a large set of labeled data, which is expensive and time-consuming to collect. This research instead looks at using vast amounts of unlabeled data to improve model performance. Their inspiration comes from backtranslation in machine translation, where human-written target sentences are annotated with model-generated source sentences. However, this approach is applied to instruction-following tasks. The method comprises two core steps: self-augmentation and self-curation. In self-augmentation, the model generates instructions for a web corpus, turning it into candidate training data. However, not all generated data is useful. This brings us to the next step, self-curation. Here, the model uses its own outputs to evaluate and select high-quality examples for further training. This iterative process improves the model at each step. Let's talk about the nitty-gritty. The initial phase involves a seed dataset of human-annotated instruction, output, pairs. These are used to fine-tune a backward model, which then generates candidate instructions from unlabeled web data. As you can see in Figure 2, the task diversity in both seed data and augmented data shows the potential to cover a broad array of instructions, adding diversity and richness to the training set. Self-curation enhances data quality by using the model to rate and select better training examples iteratively. This refinement drastically improves the model's performance over time. Look at Figure 3, which compares the performance of data sets with and without self-curation. Clearly, self-curated data significantly outperforms non-curated sets. The model they developed, named Humpback, excelled on the alpaca leaderboard. Compared to other non-distilled methods, Humpback showed superior performance, illustrating the effectiveness of this self-alignment approach. They even calculated a data scaling coefficient, alpha, to measure data efficiency. This coefficient was higher for their model compared to others, indicating their method is more efficient in utilizing training data. They evaluated their model across multiple benchmarks, including AlpacaIval and various NLP tasks. The results were promising, showing improvements in both response quality and task diversity. Figure 6 illustrates human evaluation results, where Humpback's performance was often preferred over other open-source and proprietary models. Despite its promising results, the method is not without challenges. There is potential for bias amplification from the web corpus and safety concerns around sensitive topics. Future work may address these issues by incorporating red teaming and safety mechanisms into the training process. In conclusion, instruction backtranslation offers a scalable and efficient way to improve language model performance using unlabeled data. That's all for today's deep dive. Don't forget to like and subscribe to stay updated with the latest in AI research. See you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.